the dark heart of the Scutum Centaurus arm, matter begins to awaken. Gravity has already begun its merciless war. Vast clouds of gas and dust are violently crushed toward the center. Temperature and pressure push reality itself to its limits. Chaos is trapped within a single point, and matter can no longer resist. Darkness is torn apart, and the greatest titan of the universe opens its eyes. Shockwaves ripple through the nebula, and what is born is no ordinary star. You have reached the place where the reign of the sun ends. Before you stands Today, we leave familiar harbors behind, abandoning the safe waters of the solar system and setting course for the heart of darkness, beyond the dusty veils of the Scutum constellation. We depart from Earth. Even at the speed of light, this journey exceeds a human lifetime. The moon is left behind in a second. Mars slips into the darkness within minutes. As we plunge into the interstellar void, our home fades into invisibility. Centuries pass, millennia drift by. We glide toward the Scutum Centaurus arm, one of the galaxy's densest, most chaotic regions. A stellar nursery where violent stars are born. Then, behind thick curtains of dust, an unfamiliar glow begins to emerge. It is nothing like the piercing light of ordinary stars. This light is deep crimson, ominous, like a wound torn into the fabric of space. As we approach, the scene transforms. What lies before us no longer resembles a star. It is a colossal ocean of plasma, boiling, endlessly reshaping itself, locked in a silent struggle against its own gravity. Behold, Stephenson 218, a red supergiant. Numbers fail to capture this sight, but we must try. Its radius is 2,150 times larger than that of the Sun. Saying the number is easy, understanding it is not. So, let us bring it home into scales we can truly comprehend. Imagine this: if, by some cosmic sleight of hand, we replaced our Sun with Stephenson 218, what would happen? At the center, the Sun is no more. In its place looms this red giant. In the very first second, Mercury would be gone, not merely burned to ash, but instantly vaporized, dissolved deep within the star's core. Venus, that beautiful, hellish world, would simply vanish into the void. And Earth, our blue home, our history, our wars, our memories. The atmosphere of Stephenson 218 would have already swallowed our entire orbit. There would be no sunrise because we would be inside the star itself. But the horror does not stop there. Mars would be consumed. The asteroid belt, with its millions of rocky remnants, would melt into a sea of plasma. And Jupiter, the guardian of the solar system, that gas giant would shrink into something no larger than a marble beside this monster. Jupiter would be gone. Even Saturn, with its majestic rings. The surface of Stephenson 218 would stretch beyond Saturn's orbit. Think about that. The vast billion-kilometer gulf between the Sun and Saturn, filled entirely by a single star. If you tried to fill this star with suns, not one, not 100, not 1,000, not even 1,000,000. You could fit 10 billion suns inside Stephenson 218. 10 billion copies of the star that gives us life, lost within the belly of this titan. This is not a volume the human brain can visualize. The universe has an absolute speed limit, the speed of light, 300,000 kilometers per second. Light is so fast that in the time it takes you to snap your fingers, it could circle Earth 7 times. Consider our Sun. A photon traveling around its equator would complete the journey in just 14.5 seconds. Now, imagine placing that same photon on the surface of Stephenson 218. It departs, racing at the speed of light. Minutes pass, hours pass. The photon still has not returned to its starting point. To circle this star once at light speed would take 9 hours. Let that sink in. Light needs mere seconds to orbit the Sun, but nearly half a day to encircle Stephenson 218. This is how the star demonstrates just how violently space and time can be stretched. So, how did the universe construct a giant that pushes the laws of physics to their limits? Stephenson was not always the red, bloated behemoth we see today. Just 20 million years ago, when it first emerged onto the cosmic stage, it was the complete opposite of its current form. Blue, furious, and extraordinarily dense. But mass is the curse of stars. Stephenson 218 consumed its fuel at an extraordinary rate. Yet this was not merely the exhaustion of fuel. It was a deadly dance of the elements. At its core, nuclear fusion raged. Hydrogen atoms collided violently, fusing into helium, the star's ash. But when the hydrogen ran out, the balance shattered. The core could no longer produce energy, and it collapsed under its own weight. This collapse ignited a thin shell of hydrogen surrounding the core in a runaway inferno, a process known as shell burning. As the core shrank, the outer layers were blasted outward. The thermostat broke. The inside collapsed while the outside exploded. That was the moment the monster awoke. The blue star screamed as it expanded, cooled, turned red, and swallowed everything in its path. This was not controlled growth. It was a dying star's final, desperate reflex to escape death. But such size comes at a price. Stephenson 218 is not solid. It does not even possess a true surface. It is a star in the act of dying. Its outer layers are so diffuse that if an indestructible spacecraft entered its atmosphere, you might not even realize you had touched the star. Scientists call this a hot vacuum, technically near empty space, yet thousands of degrees hot. It is less a hellscape than a crimson ghost city. Towering convection cells rise, each one the size of a star. Plasma rivers flow for millions of kilometers, slowly rising, cooling, and sinking again. Gravity at the surface is so weak that the star struggles to hold itself together. Every second, material weighing millions of Earths is stripped away by stellar winds. It is a bleeding giant. Its size is its death sentence. The rule of the universe is simple. The brighter you burn, the faster you die. Our sun will live for 10 billion years, slow and steady. But titans like Stephenson 218 live fast, burn bright, and die young. It is nearing the end. Perhaps a few million years remain. Perhaps only a few 100,000. In cosmic time, that is a heartbeat. Inside its core, elements battle. Hydrogen is gone. Helium burns, then carbon, neon, oxygen, until finally, iron. Iron is the killer of stars. When the core turns to iron, fusion stops, and nothing remains to oppose gravity. When that day comes, this region of the universe will witness unimaginable violence. The star will collapse inward in seconds. Then, supernova. The explosion will outshine billions of stars combined. If it occurred near Earth, our nights would turn to day. Shockwaves would sweep surrounding nebulae, seeding the birth of new stars. Death will give rise to creation. And what remains? The core will continue collapsing. Atoms will be crushed, neutrons will merge, space-time itself will tear. A black hole will be born. The largest known star will become one of the darkest objects in the universe. A titan that once held 10 billion suns, compressed into a point only kilometers wide. The creator of light will become its devourer. How ironic. Yet, this darkness is not an ending. It is a cosmic seed. The elements scattered in Stephenson's final breath, oxygen, carbon, iron, will drift through space for billions of years. One day they may gather within another nebula, new stars will ignite, new worlds may form, and perhaps on one of those worlds, beings will gaze into the sky, never knowing that the iron in their blood was forged in the heart of a king who once